Ladies and gentlemen, if you are just logging into this webinar, welcome to this webinar organized by UONS Singapore in collaboration with Institution of Mechanical Engineers. And while waiting for the webinar to start, I would like to first making sure that your video is off, or probably your mic is off. Just in case you have any questions during the webinar, you maybe use the Q&A button, which is under this screen, to raise out any questions so that I will be asking the question on your behalf to the panelists. Once again, good afternoon, ladies and gentlemen. Welcome to the research seminar, which is brought to you by the UONS Singapore in collaboration with the Institution of Mechanical Engineers. Today, we are honored to invite Engineer Chua Yaw Loong, the lecturer at the Department of Mechanical Engineering, University Tenaga Nasional, Malaysia, who is also the Vice Chair of International Young Member Committee of IMEchE, to present on his research topic on improving creativity in mechanical engineering design process. First and foremost, we would like to invite Professor Caroline Chan, Pro-Vice Chancellor, Singapore, and Chief Executive Officer, UONS Singapore, to give an opening address. Prof. Chan.
Good afternoon, everyone. How are you? So thank you very much for joining us in our exciting webinar for today. So with the title for the webinar is Improving Creativity in Mechanical Engineering Design Process. So my name is Caroline Chan, and I'm the new Pro-Vice Chancellor and the CEO of the University of Newcastle, Australia in Singapore. The University of Newcastle is a research-intensive university, and we rank #1% of the world university. And we have great researchers as well as academics who are doing research to do a lot of discoveries, but also to challenge the conventional thinking and breaking a new ground in the education, in the research, as well as change the lives of a lot of people and our students. And we work very much with the industry and the community partners in Singapore, as well as in the Asia Pacific regions. And for that reason, we deliver these seminars. And I'm very excited to present the today webinar together with the Institution of Mechanical Engineers. And also I would like to welcome our distinguished speaker, Engineer Chua Yaw Loong, which is from University Tenaga, Malaysia. So we are planning to have many more interesting research seminars this year. And I do look forward to your participation and collaboration in this research seminar. So with that, welcome everyone again. And I would like to thank everyone who helped with the organizing this seminar, especially my staff. And I can't mention many of them, but in particular, Charles and Idian, who's going to moderate these sessions. So Idian, I will pass this on to you now. Thank you.
Thank you, Caroline. And now I would like to invite Prof. Chan as well as Engineer Chua to be with us here for a very quick virtual group photo.
Okay.
Okay, right.
I'm not allowed to turn on my video. No, I can, yes.
Yep. Yes.
Okay.
All right, a quick one in 3, 2, 1. Okay. Thank you.
All right.
Thank you, Prof. Chan. Ladies and gentlemen, if you have any questions for our speakers during the presentations, you may enter your questions in the Q&A chat box, which is actually available underneath your screen. And we'll be addressing the question on your behalf. Now, please allow me to provide you with a brief introduction to our speaker today, Engineer Chua Yaw Loong. Engineer Chua is a lecturer at the Department of Mechanical Engineering at the University of Tenaga Nasional, Malaysia, and his research interest is in control system engineering, renewable energy, and engineering educations. Engineer Chua is also the current vice chair of International Young Member Committee of IMEchE. Right, just realized that I forgot to introduce myself as well. I'm Ian, the lecturer in the mechanical engineering in the UONS Singapore, and your moderator today as well. Now, without further ado, I would like to invite Engineer Chua to present his research. Engineer Chua, the floor is yours. Engineer Chua, you are muted right now.
Okay. All right. Thank you very much, Dr. Koh. So let me share my screen first. All right. So can everyone see the slides?
Yes, it's clear.
Okay, good. So first of all, thank you to everyone who are present here today for taking up your time to attend to this seminar or webinar, if you want to call it. So my title of presentation will be Improving the Creativity in Mechanical Engineering Design Process. So a little bit background about myself. I'm a registered chartered engineer with the Engineering Council of UK. I'm also a registered professional engineer with the Board of Engineers Malaysia. Currently, I'm a member with the Institution of Mechanical Engineer as well as a graduate member with the Institution of Engineers Malaysia. So I graduated with Bachelor of Engineering in Aerospace from the University Putra, Malaysia in year 2000, 20 over years ago. And I furthered my study in control system in University of Sheffield in 2004. So over the years, I'm very passionate about engineering educations, and I do a lot of volunteer works for the Institution of Mechanical Engineer as well as the Institution of Engineers Malaysia. Currently, I hold the position for the STEM Promotion Subcommittee Chair for the IEM. And as Dr. Koh mentioned just now, I'm also currently the Vice Chair for the International Young Members Committee. So I'll move on to my presentation outline today. So I will start off with a simple introduction about creativity and why we need creativity, things like that. Follow up with a detailed explanation about creativity and engineering design and how they are actually hooked up or linked. Then I will share with you the methods that I use to improve the creativity of mechanical engineering students by using creativity training, where I develop a module called the CTSM. And it is CTSM stands for Creativity or Creative Thinking Skills Module. And I will share some of the results that I found from my research work, and I will end my presentation today with some concluding remarks from that. So moving on, introductions. So the first questions that we'll ask here today is, who are engineers? What does engineers do? So in a very nutshell or in a very general term, engineers are people who actually design, some will just give you, they design products, they design solutions, they give you solutions to problems. So that is especially in technical problems, okay, technical difficulties, things like that. So that is a very, very layman term for everyone to understand, those who are not from the engineering background. So, and then the next question is, why is creativity needed in the 21st century? So recent research has indicated and illustrated that many developing countries are actually moving away from a production-based economy to knowledge-based economy. And because of this paradigm shift in the economy, a lot of these countries are actually in need. Okay, they are seriously in need of a high pool, a very great pool of engineers that are highly skilled, very creative and innovative. And when we talk about the Industrial Revolution 4.0 or IR 4.0, the challenges brought by these industrial revolutions are much, much greater than the past. And that's where your creativity, your innovations, your skills must come in And sadly, the scenario that we see here right now today is that research found out that our so-called young graduate engineers, the young graduate engineers are lacking in many of the soft skills. Soft skills here means that like communication skills, and one of it is the creative thinking skills, one of it. Now that leads us to come and think, what is the source of this problem? Where does this started? It all started with our current engineering education systems, okay? The institution of higher learnings, whether it's polytech or universities or even colleges. So in many of the research that was published here, all over the world, not just only in Malaysia, Singapore, even in the US, even in the Hong Kong, China, Japan, same trend were observed. Engineering students nowadays, the young ones, they are not well equipped with industry-focused soft skills such as creativity. And in many of these engineering subjects, we have some core engineering subjects such as related to engineering design, and these are actually related, highly related to creativity. Okay, these are highly related. So what can we do? What are the skills that these engineering undergraduates need? So in 2006, a guy called Kastner, together with his team of researchers, basically done quite extensive research, and they identified a set of skills that are actually critical for the graduates to survive. The word here is survive in the 21st century. So if you look at the right-hand column in the table here, some of the applied skills that you can see here, there's a list. The first thing there is critical thinking, problem solving, communication skills. Going downwards, you see creativity, innovations. So this is a survival skill. We are talking about surviving in the 21st century, which is where we are right now. Okay, so this is the general situations, the background, the problem that we are facing right now. Okay, so my next presentation topic would be on the creativity and how is it related to our engineering design. So first thing, what is creativity? Has everyone thought of that? Now, in our forefathers' generations, okay, forefather generations, we were told or we were informed that creativity is a so-called divine gift. You are born with this gift to a selected few. That means not everyone will have the creativity, the creative ability to come up with new things, great things. Then over the passage of time, then we have heard something called thinking out of the box. So that is a new definition, that is a new, I would say, realm for creativity. Thinking out of the box is a new kind of thinking. Then recently, researchers has managed to identify and categorize that creativity is basically a skill. It is a skill to combine and relate ideas in a new approach that is both practical and novel. The word here, novel, practical and novel. So there are a lot of definitions by different researchers, different theories available for creativity. So one of the main work done by researchers around the world was this guy called Rhodes in 1961. So this researcher actually categorized all the definitions, all the theories about creativity into four major categories. The first one that you see here is what we call a process. Creativity is defined as a process. This thing happens inside your brain, mental processing, all these things, and it's an input into the person. The next one that you see here, person. Now, this person is not the mental, it is your potential, okay, your attitude, your character, things like that. Now, the third one is what we call the press. Now, this press here is not your so-called newspaper, your article press. No, it is not. It is basically the relationship between that person with the mother nature. In other words, if our surrounding, our environment. Now, this is very, very clear with those artists, musicians. When they hear this kind of impact or input from the mother nature, they can come up with a lot of great things. And these three things are basically an input to the person to come up with something that we call a creative product. okay, a creative product. So this product can be creative in a way that like songs, musics, paintings, products, even like systems or services. Okay, so for engineering, we are basically looking at the first two, which is the process and the product on the first level, the first level there, process and product. Whereas for the person and the practice is more towards the psychology. So I will not go into this person and press. So for product and process, I will deal with, I will give you a more detailed definition. So in 2015, okay, a professor from Australia, Professor Dr. David Cropley, okay, he's from Australia, University of South Australia, if I'm not mistaken. He clearly defined the creativity of a product, okay, that consists of these four categories: effectiveness, novelty, elegance, and genesis. So in terms of creativity, we talk about, usually when we talk about paintings and songs, musics. So the first thing that we talk about creativity is novelty, the originality, the uniqueness of that particular product or that particular artifact or things like that. Okay, so that's why you see the novelty there. There must be a novelty. But when we come to engineering, novelty alone is not enough. You must have a prerequisite requirement, meaning to say that you must fulfill something before you get to the novelty. And that thing in engineering, we talk about efficiencies. Everybody talk about efficiency. How efficient is your solution? How efficient is your product? How many percent? What is the efficiency? 0.9, 0.7, things like that. So that is the very, very fundamental criteria for a creative product before coming into the novelty. Okay. Then the third criteria for a creative product, we talk about elegance. Now, elegance is something that we talk about giving a wow factor. A wow factor like, oh, this thing, this product, this artifact is very beautiful. The wow factor is, wow, I never thought that this thing can be done in such a way. So that is the so-called wow factor. And the last one, which is very hard to achieve, is what we call the genesis. So according to Dr. David Cropley, this is the solution or the product that you come up with is able to solve a fundamental problem that nobody even know that it existed until this product comes out. And then, oh, we have this fundamental problem, and then we didn't even realize that it exists. So that is the creative, the last criteria for a creative product. So this is the definition and how we measure creative product. For process, now one of the very famous researcher in creativity, Paul Torrance, okay, so he come up with these particular definitions of creativity in terms of a process. It's a process of becoming sensitive to problems, deficiency, gaps in knowledge or missing elements, disharmony, and so on. Then you need to identify the difficult, looking for solutions, making guesses, and formulating hypotheses about the deficiencies, testing those hypotheses and retesting this, and possibly modifying your solutions and retesting them again, and finally communicate your solutions, the results. Now, this definition of creative process is very, very in line and in tune with engineering design process stages as defined in the world. Now, in engineering design process, basically, this is the four stages here. The problem identification, we started off with problem identification. Then we have the idea generations, idea promotions, and idea implementations. So the first two stages that you see here are where the creativity is heavily related, is creativity-oriented work behavior. Okay, so because why? Problem identification is actually in line with the process of becoming sensitive to the problem. You can identify where is the gap, where is the missing element. And then idea generation is about making guesses, searching for solutions, formulating your solutions, your hypothesis, so on and so forth. So I already introduced to you what is a creative process, what is a creative product, defined by Paul Torrance as well as David Cropley. So they come up with the definitions and they come up with a measurement, how they measure this creative process and how they measure the creativity of the product. So for Paul Torrance, he developed a very world famous renowned TTCT. We call it the TTCT, which is the Torrance test of creative thinking. So TTCT basically consists of two particular domains. One is the verbal, that means we are talking about using alphabets or words. And another one is using figures, figural forms A and B, which consists of two forms. It means we're talking about using sketches, drawings, where engineers, we usually do, especially mechanical engineers, we do sketches of our products, things like that. So this TTCT, figural form A and B, measures the following 5 abilities, which is the first one, fluency, originality, elaborations, abstractness of title, and resistance to premature closure. Now, what are these 5 abilities? Fluency is the ability of the person to come up with a lot of ideas, a lot of sketches that are relevant. It must be relevant to the solution. It must be relevant to the title, things like that. That's why it's called fluent. Very fast, you can come up with the solutions. Now, originality, the word original, it tells you something about, I want the thing to be original. It must be statistically unique, novelty there. Elaboration, the word elaborate tells you that we are talking about details. You are able to give a lot of details inside your drawings, inside your figures. Now, the 4th ability, abstractness of title. 2 keywords here, abstract and title. So this is ability of the person to first organize the ideas and synthesize it and present it in a different form. Okay, you organize, synthesize, and present it in a different form. Okay, the last one is resistance to premature closure. So this is the ability of the person to have his mind open long enough, to stay open-minded long enough to accept new informations, new ideas, new changes before or jumping into the conclusion or making the decisions. It must be long enough, right? So these are the 5 things. For creative product, Professor Dr. David Cropley, okay, come up with this inventory. Okay, this inventory called the Creative Solution Diagnosis Skills. Okay, that consists of 24 items that measure again 5 items here. These 5 items, as mentioned here, is relevance and effectiveness. We talk about the efficiency of the solutions, whether it's a product, it's a service, it's a, what do you call that, the SOP, things like that. Then the second one, problematizations and propulsions. Basically, we are talking about the novelty here. We split the novelty in 2 particular domains. And the last one would be the elegance and genesis, as I explained previously. Now, driver for engineering design. Why you see all this kind of engineering design? It's basically the changes that happens around the world or around the environment, around our surroundings, that drive a lot of engineering designs here. These kind of changes that happens will actually give rise to new needs. New needs means that now we have a new problem that we need to solve. And as I mentioned earlier in my first slide, who are the engineers? These problems, engineers will actually comes in and give their design. They design the solutions, they design the problem, the product, design the services to give a solutions to the changes. Now, I will give you 2 particular examples how this thing comes in. Okay, so we are all affected with currently the so-called COVID-19 pandemic. So that is basically with the appearance of the COVID-19 suddenly, okay, at the end of 2019 and then struck here somewhere around early 2020 last year. Because of that, there was a sudden surge of need. Okay, there was a sudden surge of need for a lot of PPE, personal protective equipment, things like your face mask, things like your 3-ply mask for the doctors, or even protections for our medical frontliners and our citizens, whether it's Malaysia or Singapore. Okay, so there's a sudden surge of need for that, and then there was a sudden shortage for hand sanitizers, things like that. That is the problem now. We identified there's a sudden surge, and our manufacturing company or our company production speed is not able to cater to the sudden surge of need. So engineers have to come in and increase the productivity, come up with design that we now suddenly need a lot of PPE, but until we have that increment in the supply, how are we going to protect our medical frontliners? How are we going to give protections to the doctors and nurses, okay, or the paramedics on the front line? So these are some of the examples. So when it first came out, we are having a lot of shortage of masks for our doctors. But engineers working with the doctors, they say, hey, we don't have this one until the manufacturing, and then the manufacturing are closed. When they are back in operations, they increase their operation. We had to sort out how do we solve this problem. So they were, I would say, there were works done on, using scuba diver mask, where the scuba diver masks were actually modified, changed. They identified the problem, or the filter inside them must be replaced by a medically compliant filter for bacteria or virus filtration, so that the doctors can use this again and again, can be reused and not throw away, and then we have a lack of masks at the moment. The next thing was, this was done in Malaysia, where one of my friends was actually involved, is during the explode of the COVID-19, there was not so many information about how the transmissions and how to protect the medical frontliners. So the engineers in Malaysia actually worked with medical doctors, and then they designed, developed, and built these two so-called the combat unit. They call it the combat unit, coronavirus mobile test unit. This is the unit using container, the normal container that you see in the port. Okay, and then they modified it with the proper ventilation, with the proper insulations, where the doctors and nurses will enter from one side, and there is an insulated divider. There is no direct contact with the so-called PUI, the patients under investigation, and then they come in from the other side, and then they do the swab test. So this is one way they protected the medical frontliners with this kind of quick, easy to use, and what they call that it can be mobile anywhere in Malaysia at that time. So this is how changes in the environment, and then there's a sudden spike, and then there's a need and there's a problem. Engineers can actually work and come up with solutions, which is very creative. So in the engineering design process I mentioned just now, we are involving in 4 stages: the problem identifications, the idea generations, idea promotions, and idea implementations. As I mentioned just now, we talk about the first 2 stages are really creativity dependent. We're talking about coming up with new ideas for difficult issues like COVID-19 when it first came out. And we are searching for new working methods, new instruments, new techniques, and generating original solutions for that particular problem, and evaluate the innovative ideas. So the first stage I mentioned just now, problem identification. What is that all about? It's basically a very systematic process to identify what is your root cause of the problem. What is the point? What is the, you cannot give the wrong root cause. No, you must know what you are tackling. Only when you have identified your root cause correctly, then only you can come up with your so-called countermeasures or interventions or response, you want to call it, which will be in your second stages. Okay, second stage is where your idea generation, you need to generate a lot of countermeasures, a lot of responses to tackle this problem. And this is where creative thinking comes in, whereas the so-called divergent thinking and the convergent thinking. So in the divergent thinking, we are talking about involving a lot of generations of ideas, various ideas. Some ideas may sound silly right now. Okay, some ideas may sound silly and not practical right now, but bear in mind, doesn't matter, come up with all your ideas. Who knows, 20 years down the line, when technology is mature enough, when we have the technology, those ideas can be implemented. Do not forget about those methods. Keep it KIV, record it down. Who knows, 20 years down the line, it is possible. Then out of that, let's say 20 ideas, you make evaluations to those ideas and options. to make decisions. Now, it is very, very important that you split these two different thinking skills process so that you can actually come up with new ideas, plenty of open ideas. This is where, remember that just now, resistant to premature closures. Make sure that this is long enough. You can come up with these two stages rather than just go straight one idea, that's it. It's very important to have that. Okay, now how do I improve my students? So how did I do that? Methods I share with you. I conducted creativity training. I did creativity training to my students and I record down how did I do it. So the first stage is problem identification. You have a lot of tools you can actually use. You can Google. There are many problem identification tools around, which is very systematic. So you can have Pareto charts or analysis. You can have the fishbone diagram, or people call it the Ishikawa diagram. There are the why diagrams. There are also the 5 whys. So I will not go into this one because this is a very systematic process already. Now, the creativity part would be this idea generation tool. This is the creative thinking. Now, we are talking about generating a lot of ideas in what they call it, the idea generation stage. So if you talk about using brainstorm, I'm so sorry, you are very outdated already. Brainstorm is not the only tool that you can use to generate ideas. The newer versions of brainstorming involve brain sketching, brain writing. You can go and Google brain writing, brain sketchings. There are other tools like the 6 thinking hats. This is developed by Edward de Bono, where you actually place yourself in different hats or different shoes to look at the problem at different perspective. Okay, tools like mind mapping. Okay, this is another tool for you to generate ideas. Some people call this one concept map. There's another tool called the causal map. There's a new tool, not really new, but not many actually use this. It's called the Scamper, where you ask a series of questions related to your product. Is it possible for me to substitute this with this? Okay, Scamper is basically a acronym or abbreviations of questions related to this particular substitute, combine, adapt, modify, put to another use, eliminate, and reverse. So you ask these questions in your idea generation sessions. Can we substitute this part with that? Can we combine these two parts with this? Okay, can we modify this rather than using this? Okay, and maybe some mechanical students will have seen this, the morphology analysis or morphology chart. Okay, so these are just some of the creative thinking tools that is available. And mind you, there are many, many more. To my knowledge, there are more than 20 out there. Not only brainstorming, more than 20. So for me, for my creativity training to my students, I use what we call the instructional design model. There are a few instructional design models for you to say develop the creativity training, and I'm using this ADDIE model, which consists of analysis, design, develop, implement, and evaluate your method. Okay, whether your training is, how to say, effective or not. So these are the stages that I did. Okay, in the analysis, I analyze what is needed by the students. What are the current situation in terms of the creativity? How creative is my student right now? What are the issues that they face? So do the literature review as usual, and then I measure the creativity of the student, the creative thinking now, because I'm talking about process and product. So I need the input for the process. How is my students' creative thinking right now? And then I will need to measure their creativity of the product that they design at the end. So from the first part, analyze the needs. From the feedback, from the survey, or from the the data collected, I design based on those needs my program, my intervention program, and then develop a module called the CTSM, or the Creative Thinking Skill Module. Now, this module was sent to two development stages where we have the experts validation. Experts in this particular field that consists of 2 from the industry. They are technical directors of 2 companies who are involved in innovations and designs, and 3 academics, right? will go through the module itself and give feedback. Oh, this one you have to have here, this one you have to do this one, something like that. And I did a pilot study. So this pilot study is basically on a group of so-called students who gone through this module in a study, and then they will give the feedback about this module. So the output of this tool will be used to revise my module, my program, and to be implemented in the main cohort of the students. So the students will be measured in terms of their creative thinking, as well as the product that they design at the end upon completion of the module. And then the module is the product that they design will be evaluated by 4 experts. Okay, 4 experts here, I'm talking about 2 industrial engineers who are professionally registered and 2 lecturers who are senior lecturers who taught, what do you call that, the engineering design modules for more than 10 years. Okay, all right, so a little bit about my module development, what I did. Okay, so as I mentioned just now, I analyzed the needs. So I did preliminary studies on the creativity ability of my students, mechanical engineering students, and compare it to the norms, that means the scores by the US, which Paul Torrance has done for thousands of students, and then they come up with a norm, and we compare with the US students of the same age. And sadly, this is the case. If you can see here, in terms of fluency, originality, elaborations, and title, our students here are very weak in coming out with a lot of ideas, original ideas, coming up with the details, and able to present it in a different form. However, the students here are able to stay open enough, okay, to accept new ideas, to new informations. But this is the case. We are weak in other 4. And this is very, very supported by previous research output, where our local undergraduates basically face the following issues, where they're running short of ideas, they don't have the skills, they lack of information, not enough time, no exercise or lack of exercise to generate ideas, and be surprised, emotionally disturbed. So after identifying these needs, I need to develop a training course that actually can solve this problem. And I did that using this. This is a cognitive information processing theory. So I started off by designing my so-called my module content, which is the external stimulus. Now, it's very, very important to have your external stimulus to be attractive, okay? That can attract the attentions of the users or the students, the end users, so that they are not coming into a class or a program, or then they open up the notes and then the handouts are hundreds and thousands of words where they will just feel sleepy. No, it doesn't work. It really doesn't work. So this program, this module is basically very colorful, and then you have a lot of activities, and then they have group work, they have communications. So the slides, the contents, not a lot of work, just the right amount of words, explanations to actually for them to catch hold of the main idea of the skills. Okay, the main idea of the skills, and then immediately from the external stimulus, that means the handouts, the notes, the slides, the video, the moment they see it, they can capture it into from their sensory memory, which is their eyes, their ears, things like that, even their touch. Okay, go straight into their working memory, store in their working memory, and then I devise a very simple activity where they can repeat and recall the knowledge individually. That means they can do a very simple exercise at the end of the presentation of my skills. Okay, so they can do a simple individual exercise followed by a second activity or a second exercise where now they have to work in group. So they have to go like maybe for a site. So they have to go and see, oh, this is the thing, this is the thing. I need to have this information, where they start to look at, what I learned in the class is different. This one is here, like the cooling tower, oh, this thing, how? Then they have to look for informations online, maybe from their phone, from their pictures, or from their friend, and then they have to discuss, they have to do some discussions with their team members. So that is where you start to have those memories, those skills that they learn start to, how to say, like registered inside their long-term memory. And once it is registered in their long-term memory, it can be actually retrieved from their long-term memory and will not be lost forever because it is long-term memory. It can be retrieved for future use. So in my module, particular module, the CTSM, I purposely selected these 7 skills called the brain sketching, attribute listing, scamper, syntax, morphology, functional decomposition, and mind map, because they are simple, because of the time that they need to do this and the time allocation that I have. It's easy to use. Right, who else is on the team? So I have 2 trained facilitators to help me as well. I cannot do it all alone. And how did I implement this training and the module? So I have 2 groups of students. One is the control group, where the students will actually attend their normal mechanical design related project or subject as usual without any interference. Whereas there is another group called the intervention group. So the students will also attend the class, but in the same time, parallel to their normal classes, they also attend extra classes or extra sessions together with the trained facilitators to learn these skills. Okay, brain sketching, mind mapping, attributes, listing, functional decomposition, morphology, syntax, and scampers. They learn this one. So at the end, they have to come up with a design of a particular product, both for the control group as well as the intervention group. They have to design a product. So what was the result? What are the results that was obtained? So this is the process of getting the results until I interpret the results. So the data collection. So what data I collected in my studies? The scores. The scores for their TTCT and the scores for the CSDS. TTCT is the creative thinking about the students here. And then the scores of the product that they design at the end of the program, whether is there any difference or not. So from that scores, we need to do something that we call the normality test. We want to see whether is the score normally distributed or is it skewed to the left or skewed to the right. So only then we can actually select the proper tool for analysis of the data, because you cannot have the same tool for analysis if it is not normally distributed, and interpret the results. So how does the results look like? So as I mentioned, we have 2 different groups, intervention as well as the control group. So in the intervention group, as I mentioned, as you can see in my slides here, I have the scores for fluency, originality, elaborations, abstractness of title, and closure, premature closure. Right, the 6 is the total score of all the 5. Now, for the intervention, the students shown significant improvement in the scores in 4 out of 5 of the ability. The only ability that they did not show any improvement at all was the abstractness of the title. That means they are weak in organizing their ideas, synthesizing it, and present it in a different form. They are unable to do that. There's no significant difference or no improvement there. Whereas for the control group, how was the result? Things cannot be the same for them. Now, if you look at it, for the control group, there was no significant changes, no improvement in their ability to come up with a lot of ideas. But if you look at the originality, elaboration, abstractness, and closure, what you see is surprising. Okay, maybe to you all, but to lecturers like us, it's not. Our students' creativity, basically, if there's nothing done, their creativity, their ability to think creatively reduces over time. Now, my module, my intervention actually spans about 8 to 9 weeks time. That means at the start of the semester, this is their level. At the end of the semester, their creativity reduces significantly. And this is alarming. This is alarming. You need to do something about it. Okay? By the time they graduate, their creativity into a very alarming rate. And that is what is reported by the researchers around the world. Now, in terms of the creativity of the product that the students come up with, now the experts, okay, the 4 experts in the industry and academia outside of the universities, okay, they rated the product creativity accordingly to effectiveness, problematization, propulsion, elegance, and genesis. Now, number 12 here is again the total score of all these 5. Now, they all agree that the product that the intervention group designed, okay, the design that they've done is much more creative compared to the control group. Okay, much. Right, there is a significant difference between the control group product design as well as the the product design by the intervention group. So that is the outcome of the work that was done. So some concluding remarks from there. What can we conclude? Right. So engineering is definitely one of the fields where there is a lot of room for improvement when it comes to creativity, because we are talking about design. We're talking about coming up with solutions. You need to break from the norm, okay? Like thinking out of the box. This is not. Our generations, maybe we are talking about thinking out of the box. The next generations, there is no box for you. Just go. There's no box, okay? Now, from the results obtained, there is an urgent need, there is a need to improve and enhance the creativity of the engineering undergraduates, especially for the mechanical, because they are dealing with a lot of designing of the product, okay? And one way to do it is to give creativity training. It's a very effective way. Provide them, equip them with the skills, not just only the technical skills like how to use the AutoCAD, how to use the Creo or SolidWorks, Autodesk, but when they come up with the solutions, they have to have these soft skills to generate ideas. That is the thing that they need. Some recommendations, okay? So my work is basically on mechanical engineering design. Okay, so my pool of students are mechanical engineers. So this work can be done to other engineering. It can be from civil, it can be from electrical, it can be from petroleum, it can be from chemical, or even mechatronics or computer and communications. It can be, no problem. It should be done to all. Then we actually should be looking into other creative thinking skills effectiveness. Now, my work is only on these 7 skills. As I mentioned, there are more than 20 skills out there. Has there been a lot of research on how this effectiveness of all these skills? Not much work has been done yet. And the last one is to investigate the appropriateness of a particular creative thinking skills applied to a specific type of engineers. For instance, we can actually look into the possibility of having mechanical engineers to see whether they are more appropriate for, like, let's say, morphology. They are more effective using morphology, whereas civil engineers are more effective in their design, more creative in their design using different skills like attribute listing. And electrical engineers are more effective, more creative in using what they call that, the mind mapping. We look at this, try to match them. This is something that we can actually look into. So I think with that, okay, I come to my last slide. So for those who are actually interested in this particular topic about creativity in engineering, so there are actually quite a number of good books out there. And this Professor Dr. David Copley has written quite a lot of books on creativity in engineering. I told you he is a mechanical engineer, and his research is on engineering design and innovations and creativity. So I managed to find this book from the IMEchE digital library, and I downloaded and I went through, and then I see that's where I started to research on this. Then there's a lot of articles by Professor David Copley. Now, there are 2 famous Copley researchers, Arthur Copley and David Copley. Both are also good. Okay, there is a particular handbook on creativity as well, published by the University of Cambridge Press. And this handbook is going to give you a very thorough information about creativity. How can creativity be applied? Not just only in engineering. Creativity can be also applied in organizations, companies, their management, how they can do it when we talk about like providing services. Okay, it can be done there. and actually this book tells you how creativity can be used in not just only classrooms, but companies, businesses. Okay, so I think with that, I come to the end of my presentation. So back to you, Dr. Koh. So I will accept any questions from the floor, if there's any. Thank you very much.
Thanks a lot, Engineer Chua. Yes, indeed, there are a lot of questions from the floor here for you.
Okay. Okay.
Just try to get yourself ready for the questions that is coming to you. Right,
Okay.
now, let me read out the first question here. If creativity can be taught, what university year would you be recommending that this is taught?
Okay, it has to be definitely be in year 1 or year 2. It cannot be in year 3 and year 4 because it will be too late. Okay, because when you have, I've seen some university taught that in year 1 and year 2 as well. Yes, year 1 and year 2, because these are soft skills. It's not really technical. So I would really suggest that to be taught in year 1 and year 2.
Okay, right. The next question can be quite closely tied to the previous question that was being asked. It says that if the module is held in 1 semester, will this be sufficient to boost up the creativity among students? Following that, if the answer is no for the first question, then how long do you think the module will need to be run to increase the creativity level among students?
Can you repeat the first question first?
There's a long question. Yeah, let's sort of one by one here. Well,
Okay.
if the module is held in 1 semester, will this be sufficient to boost up the creativity level among students?
Yes, because we are exposing it to different kind of skills. It should be able so that the students can actually use it in their 3rd year or second year or 3rd year or even in their final year project when they come up with the designs for their work. So it should be enough, because in your 2nd year or 3rd year or even final year, you will have what they call that the engineering design related module, so they can continuously to use the skills that they learn either in the 1st year or the 2nd year. They can continue to use that. Is enough.
Right. So I think the next question is invalid because it says if the answer is no, how long do you think? But really, from out of my curiosity here, do you think like if the module is held like 2 semester, would it be too much for the academics or students to take on it?
For 2 semester?
Yeah, I'm just curious about it.
I think 1 semester is enough. So far, I've seen 2 universities in Malaysia are doing it. I see the one is UTM in Skudai. One particular engineering department, if I'm not mistaken, is either the electrical or electronic. In fact, they teach this one in the very first semester of 1st year.
Okay. Yeah.
1st semester, 1st year, and it's a compulsory subject.
Right.
A core subject, they call it. And then another university technology in Cebu, in Malaysia, they put this one as either the 2nd year or the 3rd year. I can't remember it. It's called Creativity and Innovations. So they all put it as 1 semester. So 2 semester is too much. 1 semester, and then you just expose them to the very fundamental of these few sets of skills.
Yes.
So that they can actually use it. 2 semester will be too much. Yeah.
Okay, right. Thanks. Now the next question coming up. Just to get your insight, since there has been a hot topic of design thinking nowadays, do you think that creativity is interrelated with design thinking in terms of complex problem solving?
Yes, they are. Yes, they are. They actually complement one another. Okay, there are a lot of research on, you can see there are a lot of research on critical thinking. There are a lot of research on creative thinking. There are a lot of research in design thinking. Okay, they actually part of a big puzzle, you know. They are actually part of a big puzzle. So they actually complement one another. Design thinking and they are quite structured. Whereas creative thinking is not, no. It's not right. You do it this way, you do it that way. No, it's not.
Right. Okay, cool. More coming up.
Okay.
Next one. So in your opinion, do you think that students in this region are supposed to be in Singapore or Malaysia? are weak in their creativity due to their earlier, which is primary or secondary education?
Definitely yes. Definitely, because why the students nowadays are actually even I think during my generations we are being spoon fed too many things until like our brain is like your brain is going to operate within this frame only. You are unable to come out from that particular frame or that border or out of the box. That is the problem with the education nowadays. That is the thing. So it's very, very important that when they go into the tertiary education, we want to break their so-called their boundaries that they work on. It's very important to break that. And then teachers in the primary or secondary schools, they don't really teach them on solving problems. No, they just ask them to memorize. That's the problem. Memorize, 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 and go by step 1, step 2, step 3, step 4, step 5.
Yep.
So it's just like, okay, if I were to give you one situation, I need to travel from, let's say, from Kuala Lumpur to KL, from Kuala Lumpur to Singapore. Tell me how you do it. Students will say, just drive a car from KL to Singapore, that's it. But will they be able to think of something that is different? Okay, like, okay, I can take a flight from KLIA to Singapore Changi. That is another solution. I can take a train from KL all the way down to Singapore. I can take a bus. I can hitch a ride if I can get one. I can walk. I can take a cruiser from Port Klang all the way down to Singapore. Why not? These are possible solutions. The problem is our students are too limited, too restricted when they were given the education during the primary. Use this only, use this only, use this only. But they've forgotten that there are many, many solutions to do it.
Right. Thank you. Yeah, it just reminds me of recently I've been telling my students that every time when there is examinations in Malaysia, that when students are asked to write an essay about a day by the beach, and normally they sure go to Port Dickson because of the model answer says they go Port Dickson, which I think is quite true.
Okay.
Yep. Right now, next questions. Why do you think students who underwent the program did not improve in abstraction aspect?
Okay, so this is related to how to say presentation. Okay, now when the students, okay, the abstractness of title is the ability of the students to organize, then synthesize, and then present it in the different form. Now you see the abstractness of title. The TTCT is about figure, drawings. Okay, they come up with a drawing, and then they have to put a title to their drawings. So for instance, they draw a ship. Can you give me a title for this particular ship? So they have the title, okay, they have to draw the ships, all these things. And then what is the title for that particular figure? They have already, they can organize the idea, they can synthesize. Can you give me something to present? So the ability to come up with a different presentation, that is where they are lacking. That is where lacking. So let's say if I have a picture about a ship, what title will you give? Normally the student will just, this is a ship. But creative people would think above that, beyond that. Okay, so I've seen some, okay, in my students' work, okay, they draw a ship and then they put their solo journey around the world.
Right.
This is something totally different from a ship, but it is a journey. It is a sailing journey of a ship. It can be going around the world, which is very general. Rather than reduce it within this confine of a ship, so he put there, now this is a solo journey around the world in a ship. So it expanded the, what they call it, the boundary, rather than just purely ship. Now it's talking about a journey on a ship around the world. So that is where they are unable to present it in a different format, different form, and expand their, what they call that, the reaches. So this is where they cannot do it.
Okay, right. Thanks. Once again, just a quick reminder to our attendees that if you have any questions that you'd like our panelists to answer, please raise them via the Q&A section located underneath your screens here. Now, let me ask the next question. Can you give some concrete examples about the level of genesis from the pyramid chart that you shown to us in the slides?
Okay, a very good example. Okay, you see this one? What is this?
iPad or
Apple.
Yeah.
Apple product. So Apple product, what do you see there? What is the thing that you can see? It's a tablet. Okay, it's a tablet. The operation system is completely different. It's not using Windows. Okay, it's not using the MS-DOS. It's not using the Windows. It completely uses a different program, okay, to run the thing. And then when they come up with this program, this Apple operating system, and you don't, I'm sure that some of you will realize that the protection towards the so-called malwares and hacking is much stronger compared to Microsoft Windows. Do you realize that? So when this thing came up, it actually protects the users a lot, and they didn't realize that. They didn't realize that until they use it. Oh, it's very hard to penetrate to Apple's software to hack the system as well. Okay. Another good example is this, our glasses. Okay. In those days, we were having this frame of glasses. Now, what do we have? We have contact lenses. Okay, we have contact lenses that totally remove the frames, remove the materials. We have this, what do you call that, the material for the contact lenses. And then it solved the problem of what? You didn't realize that we solved the problem of our irritations at the ears and the nose. We just not just only solved the problem of our so-called problem with our eyesight, but we also same time solve the problem of our irritations of the ears and the nose when we have our glasses on. So the contact lenses is another one. Okay, so I hope that one answers some of the questions.
Okay, right.
Chua, thank you so much for doing your excellent presentation. Yeah, I enjoyed it very much, and
thank you.
To our research series. I'm sure a lot would like to collaborate with you as well as Yan. Now, I have a basic question. You know, creativity is a difficult subject, especially when it's hard to quantify it. But what you did is very good. Now, my question is, creativity. You know, some, as you know, you're thinking that some we are born with it. You know, some are obviously more creative, right? Just like our children. You know, some are very creative and playful. Some are like, you know, all different types. Versus creativity, we think we can teach it. And we are academics, right? We can teach it in schools and in universities. A little bit similar to entrepreneurship. Entrepreneurship, some are born kind of, you know, they are business people, right? Versus teaching entrepreneurship is like, wow, you know, a bit difficult. So back to creativity, you're in this research. So how much do you think people are born creative versus let's say if a person hypothetically is not very creative and is an engineer, and how much can we teach that person, you know, to be very creative? Because we need that in this day and age, right?
Yes.
So what are your thoughts on it, Chua?
Okay, it's not about being born with it. It's whether that particular person is willing to accept and practice. Because creativity, as I mentioned, in our forefathers' generation, people has a wrong conception of that it is born, is a divine gift from God. Okay, but research has shown that it is not. It is a skill to, how to say, combine and relate different ideas and put it into how to call that, in a very novel approach. So it's basically a skill to combine this and put it into one final product in terms of the engineering. So the students themselves must really be able to accept this kind of trainings and use it. If you don't use it, you will lose it. That's the thing. You have to use it. That's why when the previous question, when do we start to teach them this one? It's best to start at first year. Then you teach them this one, and then slowly, when you have your projects or your modules that are related to design, and then ask them to use what you have learned before, ask them to use this, and then they start to practice every semester throughout their studies until the final year, even in their FYP project or maybe capstones or integrated design projects, if you want to call it, something like that. And then they have something like, oh, this is like inherently they already practice for so many semesters. Then when they go out and work, they can still remember, I can use this tool, I can use this, I can come up with this one with a lot of ideas. Okay, so that is where they actually, that is what they call that, the coming up with a lot of ideas. Okay, that is where the creativity work sits in. Okay, so that is the work of we as academicians lah. We have to teach them this.
Thank you. Yeah, thank you very much.
Okay.
Right, so we still have one or two more questions here. Well, the next question that popping up here is that is brain sketching a better option in comparison to brainstorming?
Definitely yes. Definitely, I've seen the difference already. What is brain sketching? Brain sketching is that, okay, it's basically, if I were to give you one, it's a group work, 3 to 4 person. So I give you an incomplete design or incomplete pictures. Let's say I give you a line, I ask you to draw a pencil. So you draw something like a pencil, within 1 or 2 minutes, how you want the pencil to be like. And then the next person, before you even finish the thing, you give it to the person sitting next to you, and then the next person give to the next person, and then they will come up with, what do you call that, his version of a pencil. Your version of pencil will be totally different from his version of pencil, and there you can see a lot of ideas in just a very short amount of time. Okay, everybody, you will be rotating. So in a very short amount of time, you'll get 20, 30 ideas straight away. So it's more effective. That's why I said brainstorming is outdated already. It's a very, very outdated method. Brainstorming, another one that I didn't really go into was brain writing. This one, brain writing, was actually meant for like those poets or songwriters or lyric writers. They are actually using this one. And then for students to write essays, good essays, is using brain writing. I didn't really go into this one because this one probably is more towards our students to write their reports. Then this would be good. Okay.
Good. I have one last question for you.
Okay.
Now, how many students are involved in this research, and for the control group, are they really exempted from taking that module? Okay,
so for pilot study, I have about 33 or 32 from different universities. It's not University of Newcastle, it's a different universities. I got the approval from that particular university to do it to a third-year students as well, okay, who was enrolled in a design module. And then for the preliminary studies, I collected about 44 students from mechanical third-year students who are enrolled in a mechanical design related module as well. And then for the main one, I have about 100 over students. Half of it is under the control group, another half of it is under the intervention group. So the control group, they have no access to the, what they call it, the intervention program. And then for the intervention group, they have to, it's voluntary basis, okay? They have to come and attend these classes, extra classes. If they want to come in, they come in. If they don't want to come in, fine. So I don't force them to come in. And so they want to learn new things. Some of the students, they really want to learn new things. So they came in from the very first week until the end. And then they say that one of the comments that I received from the feedback that I received, this is one of the most useful tools I have learned in my 3 years of engineering study. This is one of the comments that they give. I've never learned so beautiful tools that I can use in my design. This is one of the comments on me. Okay.
Okay, there being no questions, once again, thanks a lot, Engineer Chua. Spend out your time on this Friday afternoon sharing with us about your research in generating or creating awareness of the creativity among engineering students. And as you can see from the screen here, there is a QR code here, which is we are requesting you to fill in this feedback form to share your feedback with us and about this webinar. And of course, once we receive the feedback, we'll be improving our webinar and in the future. Right. So for more information, you are always welcome to log into our UNI's website to get more about the webinar as well as about this webinar, because the recording as well as presentation slides will be made available in our university website, which is www.newcastle.edu.au/Singapore. So once again, let me take this opportunity to thank every single one of you who were here in this afternoon to joining us on this webinar, as well as the organizing committee who has spent so much time in creating this platform for us, as well as doing the promotions. Not forgetting, if you have more questions, feel free to contact us through our university website so that we are able to work with you either in collaborations or perhaps in more webinar organization opportunities here. So once again, thanks a lot, Engineer Chua. Thanks a lot for all the participants here. We shall see you in our next series of the webinar. Thank you very much. See ya.
Thank you very much. Thank you all.